cheat.
Well, you guys have taught me well. All right, today we start with ratios and rates. For those of you who've had me in class before, you know that when we talk about ratios, they always look like this. And we have a number here, and a number here, and a number here, and I have to figure out what this number is here, and that's how I solve most problems, right? And what do I do to solve that problem? Does anybody remember? Cross multiply and divide. So this number times this number divided by this number. Yes, this should be an easy chapter. Super easy for y'all. It's only 4 or 5 sections long. So we'll get through it yet before spring break and get started on our next chapter.
How long till spring break?
A long time.
How many weeks?
A month. 5
That
weeks.
ain't that long.
Okay. So, talking about rates and proportion, today is just an introduction to writing rates and ratios. So this is going to be easy peasy lemon squeezy. You should not have to cheat on any of it. Okay? That means no Googling your answers. All right? So, rates and ratios. When we talk about a ratio, we're talking about the quotient of two quantities, or comparing two quantities. So everybody should have their pencil in their hand writing this definition, this first sentence right here, Mason, where it says ratio right here. You write quotient of two quantities. So when I say we're working with the quotient of two quantities, what does that mean we're doing? Quotient means we are dividing. We're going to divide those two things. When we write a ratio as a fraction, which is how most of the time they are written, we need to remember that the order that they go in makes a difference. So the first number in our ratio goes on top, and the second number goes on bottom. There are 3 ways to write a ratio. You'll see here we can write it with the word 2 in the middle. We can write it as a fraction, which is the one used most often, or we can write it with a colon in the middle. Okay? That just means we are comparing these two numbers. The most important thing is they have to stay in order. So when we write, and this is on the back of your page, when we write the ratio 15 to 23 using fraction notation, does anybody know what that's going to look like? Super simple, right? Easy peasy lemon squeezy. Next one, we are going to write $25 to $15 in simplest form. So 25 goes on top, 15 on the bottom. Those can both be divided by what? 5. So if we divide them by 5, it becomes 5 over 3.
Does it stay with the dollar signs with it, or no?
In your answer, it should probably have a dollar sign with it, yeah. I don't know why they don't here. And ratios are the one time where we're comparing two things, so you don't have to put this as 1 2/3. So we can just leave it as 5 over 3. Okay? Next, we have 2.6 to 3.1. If I'm going to write that as a ratio in fraction form, which number goes on top? 2.6. Okay, we want that in simplest form. These both have one place after our decimal, right? So the Pearson book says we should multiply each of them times 10 and get rid of that decimal point. Just turn them into whole numbers. So when we multiply both of them by 10, we end up with 26 over 31. Can 26 over 31 be reduced? Why not?
Just a guess.
Well, it was a good guess. It's the right answer, but I want you to tell me why. One's an odd number, one's an even number, right? So we cannot reduce those down. The last one we're going to look at, written as a ratio, are two mixed numbers. Okay, we dealt with this a little bit when we were talking about fractions. This is a complex fraction. So what we're going to do is turn them into improper fractions. So we take our 1 times our 5, popcorn, add our 1, and that becomes what? 6 over 5. And we're going to divide that by 2 times 10 plus 7. And when I divide fractions, how do I divide these two fractions? Flip and multiply. So I flip my second one over. So then when I multiply fractions, I multiply straight across. 5 times 27. Oh, they're going to go ahead and factor that out a little bit before they multiply. So they break this 5, or this 6, into its factors of 2 and 3. They break the 10 into factors of 2 and 5. 5 is a prime number, so it just gets that 5. 27 is 3 times 9, or 3 times 3 times 3. So those are the factors of 27, and then they can go through and be like, well, here's a 5 and here's a 5, so those cancel out. Here's a 3 and here's a 3, so those cancel out. 2 times 2 is 4. 3 times 3 is 9. So reduce down to lowest form, that ratio that we started with is actually just 4 over 9. Good? We're all good with that? So here is a way to use ratios. We're going to find the ratio of this rectangle's width to its length. So what is the width of this rectangle? 7 feet. So that's going to be our top number. 7 feet to its length. What is its length? 5 feet. So that's going to be our bottom number. So we should have a ratio of 5 to 7. We have feet over the top of feet, just like common denominators. Labels can cancel out, and you should know this from working with some of your science math, right? When we change from kilometers to meters, we have to cross out those labels as we're working through our ratios. Yeah, no, maybe.
Wait. So the width, why did this get to 5?
Oh, well, we listed them backwards. I always thought width was length with across. We listed them backwards. Thanks for pointing that out, Valeria. I was just going to go with it. So it's 5 to 7, not 7 to 5. Width is up and down, length is sideways. Mm-hmm.
So then it doesn't have a label?
It doesn't have a label. Our labels cross out, so our ratio is just 5 to 7. And when we get to our next column with talking about rates and unit rates, it'll make sense more about why these things cancel out. You're smart enough you can just do it? Well, if we're just going to jump to it, you might as well just do your homework. I can sit down. Or you could just pay attention back there.
I'm paying attention.
Okay. So, perimeter. Okay. So now we are comparing in our ratio the length to the perimeter. So we know now after our last mistake that the length is actually 7. How do we find the perimeter? Add up all the sides. So our perimeter is 24. Is 7 over 24 in lowest terms? It is. We're just going to cross out those labels. So 7 over 24 is our ratio.
And why we put the length? Why just the length? Just because?
Just because that's what the question asked for.
Okay.
Length to perimeter. So now we talk about rates. Back over, this is a vocab word on the front side. Oh, just kidding. Unit rates isn't till later. But we are talking about rates. A special type of a ratio is a rate. Rates you use to compare different things. So when we talk about miles per hour, that's a rate. Miles per gallon, that's a rate. Ounces per dollar, that's a rate. Okay? This is where we use math in real life. These things come into our real world. So when we talk about rates, we're talking about different kinds of comparisons, so we don't have the same thing on top as bottom like we did on our last one where we could cancel out our feet. So 3 miles to 33 minutes can reduce down to 1 mile in 11 minutes. Oh, it's really just going to give you the answer? Perfect. So in simplest form, we're going to write 10 nails for every 6 feet. So 10 nails goes on top, 6 feet goes on bottom. That can reduce down. That's not in lowest terms because those are both even. So that means when we're done, we're putting 5 nails every 3 feet. The next one is $2,160 for 12 weeks.
So does the first one always goes on the top?
First one always goes on the top. So $2,160 over 12 weeks. Can that be reduced down? Yeah, it can. How do you know that? Well, they are both even numbers. That's a great idea. Or it's always a good idea when you're working with rates to see if the bottom number will just divide evenly into that top number. So 2,160 is in fact divisible by 12. It is $180 every week. The next one, 360 miles on 60 gallons of gasoline. So 360 on top, that's our miles per gallon. So we want our gallons on the bottom. Is 360 divisible by 16? How many times? It is not evenly divisible. It is not evenly divisible, but they are both divisible by 8. So if we divide them by 8, that's 45 miles for every 2 gallons. Okay, lots of times that does us no good, right? We don't want to know how many miles we're getting out of 2 gallons. I want to know how many miles per gallon, per 1 gallon I am getting, right? Makes more sense. think we have one more like this before. Nope, just kidding, we do. So when we have a comparison with a 1 in our denominator, so how many miles per 1 gallon? Or how many miles in 1 hour? That is called a unit rate. So on the front of the page, a unit rate is a rate that has a bottom number or a denominator of 1. This is how we find that single gallon, or how much I get for $1. And in order to do this, you just take your top number and divide it by your bottom number. Okay, you're going to want a calculator for this. So we are going to write this as a unit rate. I get $31,500 every 7 months. So if I want to figure out what I get in 1 month, I just take my top number and divide it by my bottom number.
So but you would have to write it 31,500 over 7.
Which I did not leave you room to do. So with your calculator, you should be able to figure out what you're making in 1 month.
So if you divide those two, that's what you make.
That's going to give you the answer. So $4,500 per month, or dollars per month. Because that 1 is in front of our month, it is a unit rate. It's for every 1 month. But lots of times we just drop that 1 out of there. It's like that invisible 1 that we don't talk about. It's just per month, per hour, per mile. Okay? So next, we're looking for how much we can pay per unit, which is called a unit price. Same thing, we're just figuring out how much each unit costs. So a store charges $4.80 for 32-ounce container of laundry soap. What is the unit price in dollars per ounce? So we have $4.80 over 32 ounces. We want to know how much 1 ounce costs. We simply divide. So type it in your calculator. 480 divided by 32. What'd you get, Valeria? 15 cents an ounce. So it costs 15 cents per ounce. I don't know how many of you are grocery shoppers. No, none of you yet? Lots of times the stores figure this out for you and put it on their price tag already, so you can compare price per ounce. I just bought dishwasher soap at Walmart yesterday. Nope, Saturday. And normally, if you buy the little bags of replacement dishwasher pods, they're cheaper than if you buy the whole thing, the container. However, Walmart's little stickers said it's cheaper for you to buy this plastic container of pods instead of this replacement pack to pour in the plastic container you already had. And I said, liars. That's what I said. So guess what I did? I whipped out my phone and I went, well, I'll be golly. It was cheaper. It's cheaper for them to package it in a hard plastic container than it is in a throwaway little Ziploc bag.
Doesn't seem right.
No, it really doesn't. It really doesn't. I don't know if they just have you trained in your mind to think that replacement ones should be cheaper and so they charge more for them.
Maybe they're just trying to confuse you so you don't buy them and eat
Well, shoot, because I was really hungry. I was hoping to go home for a snack later. Last example. So we have 2 bars of soap, or 2 packages of soap. One is 4 bars for 99 cents. The other is 5 bars of soap for $1.19. So we're trying to compare these. So I have 2 different ratios I need to set up. Look at the answers and figure out which is a better buy. What's my first ratio, Laura? What's my first ratio that I'm going to write? 4 bars of soap over 99 cents. You're right. My second ratio I'm going to write, Mason?
5 bars of $1.19.
Over $1.19. Then I'm going to divide. I have to take 4 divided by 0.99, and I have to take 5 and divide it by 1.19. Then I'm going to compare those 2 numbers. So 4, and we have to approximate these because they don't work out to nice even cents. So we round. That's why it's important to know how to round. Use that number after our 2 cents of money, so our hundredths. We look at our thousandths number to round how many cents it's going to cost. 4 bars for 99 cents is approximately 25 cents a piece. 5 bars for $1.19 is approximately 24 cents a piece. So by buying 5 bars instead of 4, you save money. However, you do not save money if you buy 5 bars of soap and only use 2 and throw the other 2 in the trash. Okay? So common sense comes into play as well.
Oh, we use bacon?
Bacon?
Bacon.
There was bacon on
Bacon.
Where?
there. Right there.
Oh, bacon. Bacon, yeah. Just because we're rounding. It's approximately 25 cents and approximately... Sorry, I was looking for the word bacon.
But they're going to want bacon on the assignment, right?
Probably if you have to type it in.
Okay.
Okay, questions. Perfect. You can use a calculator to do this division today. Please do not Google or use Mathway. Use your brain.
Calculator?
Use a calculator.
It's a smart calculator.
Use your calculator.
I don't got one.
I use Google. What?